Today, we are looking at something that is just absolutely mind-blowing, one of the most terrifying, awe-inspiring, and frankly apocalyptic phenomena on planet Earth. We're going to decode the anatomy of a fire tornado. It's this incredibly rare, visceral fusion of intense fire and extreme weather that completely defies everything we think we know about how storms actually work. Okay, let's dive into this. Seriously, what happens when a wildfire gets so unbelievably hot that it literally rips the atmosphere open and starts dictating its own weather? To wrap our heads around this, you kind of have to throw out your standard definition of a thunderstorm. I want you to imagine standing in a landscape where the air is just bone dry, the wind is howling, and the entire horizon is just a solid wall of red. And then, suddenly, a massive, spinning vortex of flame reaches from the ground directly up into the sky. Atmospheric scientist Neil LaRue hit the nail on the head when he described it. He said, "It's a hellscape of midnight at noon and raining fire." Just picture that for a second. The smoke and ash are so incredibly thick, they completely blot out the sun in the middle of the day. But it's not dark because the sky is literally raining burning embers all around you. It's a terrifying escalation, and we're going to break down exactly how nature manages to build this absolute monster. Section 1. Nature's bizarre atmospheric anomalies. You know, our atmosphere is incredibly complex, and it produces a lot of really strange phenomena. But as we're going to see, some of these are little more than spooky light shows, while others are absolute forces of deadly physical destruction. For instance, think about this comparison. For centuries, sailors out at sea during thunderstorms would look up at their ship's masts and see St. Elmo's fire. This ghostly, continuous blue plasma glowing in the dark. It looks totally terrifying, but it's really just a harmless corona discharge, basically a continuous spark in ionized air, totally safe. But a fire tornado? Yeah, that is the exact opposite. We're talking about a combustion vortex driven by 2,000-degree heat and massive physical destruction. It doesn't just glow, it consumes. Section 2. Anatomy of a fire tornado. Now, what's really interesting about this slide is how we can look right under the hood of this phenomenon to see the precise mechanics, the actual physics that turn a regular wildfire into a spinning column of destruction. It all starts with something called wind shear. Imagine fast winds high above the ground, running into slower winds down near the surface. They collide and create this horizontal roll of rotating air, almost like an invisible slinky, just rolling across the landscape. Then you introduce the intense, massive heat of the wildfire. Hot air rises rapidly, right? That creates a massive updraft. And this updraft acts like a giant telescoping arm that grabs our invisible rolling slinky and just pulls it straight upward. The roll stands upright, stretches out, and suddenly, boom, you have a violent, vertical, spinning vortex of fire. And this creates what meteorologists call a pyrocumulonimbus cloud. I know, it's a huge, fancy word, but it literally just means a fire-generated thunderstorm. Once that vortex starts spinning, it kicks off this vicious positive feedback loop. Usually, hot air rising from a fire would eventually mix with cooler air and just kind of dissipate. But because this column is rotating so insanely fast, it acts like a giant brick chimney. It traps all that heat inside, refusing to let the cool air mix in. So the updraft gets stronger, pulling in more wind, which just feeds more oxygen to the fire down at the surface. But here is where things go completely into overdrive. Latent heat. Inside that massive column of smoke, there's actually invisible water vapor. As this hot plume shoots higher and higher into the freezing cold upper atmosphere, that vapor is forced to condense into visible liquid cloud droplets. And when water changes phase like that, it dumps a tremendous amount of heat right back into the atmosphere. This latent heat essentially doubles the energy of the storm. The cloud basically gets a mind of its own and develops vertically at just a terrifying rate. Section 3. Whirls versus true tornadoes. Now, the crucial point is making sure we don't confuse a little campfire oddity with a true, full-blown atmospheric disaster. These terms get mixed up all the time, but meteorologically speaking, there is a massive difference in both scale and danger. You've probably actually seen a fire whirl yourself. If you've ever had a bonfire or a backyard fire pit on a breezy day, you might see this tiny 1 or 2 foot spinning flame dance around in the ashes for a few seconds. That's a fire whirl. A true fire tornado, on the other hand, we're talking up to 500 feet wide, stretching hundreds of feet into the sky. It doesn't just react to the wind, like we just talked about, it literally creates its own massive destructive weather system. and the physical forces at play inside that system are just staggering. The winds inside a true fire tornado can easily top 140 miles per hour. That puts it right on par with an EF3 tornado. So we're not talking about gusts that blow your hat off. These are winds capable of crumpling large steel structures like tinfoil. They literally pack enough lifting force to pick heavy 20-wheel trucks straight up off the asphalt and magically toss them through the air. But remember, this isn't just a windstorm. You are dealing with a core temperature of 2,000 degrees Fahrenheit. It is an absolute wall of unimaginable heat. So you aren't just fighting the brute physical force of the wind, you are fighting flaming gases and superheated debris moving at literal race car speeds. Section 4. History's deadliest firestorms. Let's move to and see how this builds when these rare, monstrous conditions converge over populated areas. Because throughout history, these outlier events have left unimaginable destruction in their wake. If we walk through this chronologically, you really see the sheer human cost of these outlier events scaling up. Back in 1871, the Great Peshtigo Fire in Wisconsin generated a massive fire tornado with 100-mile-per-hour winds, claiming 2,000 lives. That actually makes it the deadliest U.S. fire disaster ever. Then jump to 1923, right after the Great Kanto earthquake in Japan. Thousands of people fled to a riverbank, thinking they'd be safe, only to be cut off by a 300-foot-tall funnel of fire that the locals called a dragon twist. Almost 45,000 people perished in that single fire tornado. And then, in 1926, a lightning strike on an oil reservoir in San Luis Obispo, California, spawned hundreds of these fire whirls, which finally led to the very first documented scholarly study of the phenomenon. In fact, the meteorologist who studied that 1926 fire, J.E. Hisong, documented some incredible eyewitness accounts to give us a real sense of scale here. He noted a whirlwind that, quote, picked up the Sieber cottage, lifting it several feet in the air and carrying it about 150 feet north, where it was dropped in a field, a total wreck. I mean, wow, that puts a very human, visceral perspective on the sheer lifting power of these massive storms, doesn't it? Section 5, Surviving a Fire Tornado. All of this brings us to a frankly terrifying question. What on earth do you do if you find yourself directly in the path of one? Imagine for a second you're trapped in a convenience store. The roar outside sounds exactly like a commercial jet engine taking off, and this towering vortex of fire is charging straight toward you at Usain Bolt speeds. And this brilliantly illustrates your actionable checklist if you were ever caught in this nightmare. First, get underground if you possibly can. A deep basement is your absolute best bet. If you can't do that, stay far, far away from windows, because those 140-mile-per-hour winds are going to turn any glass into flying shrapnel. Second, stay as low to the ground as humanly possible. Smoke rises, right? So your only chance of finding dense, breathable oxygen is hugging that floor. Finally, breathe through wet cloths to filter out the suffocating flying ash and burning particles, because at this point, you just have to wait it out. Now, you might be sitting there wondering, why not just run or drive away? Well, the answer is something called long-distance spotting. The incredibly powerful winds of a pyrocumulonimbus cloud throw these glowing, burning embers way up high into the air and launch them over a mile in advance of the actual storm. So long before the tornado itself even reaches you, the sky is literally raining fire in a mile-wide radius, instantly igniting green spaces, homes, and the roads ahead of you. Outrunning it on foot is nearly impossible because it's systematically surrounding you in a sea of flames before it even arrives. The really sobering reality we have to face is that these are no longer just purely historical anomalies. Globally, we're seeing lengthening fire seasons and significantly larger blazes. And that means the atmosphere simply has vastly more opportunities to produce these extreme, unpredictable conditions. We're at a point where even veteran frontline firefighters, people who normally rely on decades of experience to predict how a fire will behave, are increasingly coming face to face with these extreme, town-leveling outlier events they have never seen before. It's rewriting all the old rules of thumb. So we've decoded the incredible, terrifying physics of how a wildfire bends the atmosphere entirely to its will. But it leaves us with a pretty stark reality check. As our global fire seasons stretch longer and the blazes grow more intense and fuel-rich, we have to ask ourselves, are we truly prepared for a future where fire doesn't just react to the weather, but actually dictates it? It's definitely something to think about.
As always, subscribe to our channel, like the video, and comment below. There are also some links in our description that you may find useful. See you in the next episode. Bye-bye.